Hello class, Mr. Zaghetti here. Today our new lesson is on radical equations and extraneous solutions. In order to solve a radical equation, we need to isolate the radical and then square both sides, or raise it if it was a rational exponent to the reciprocal power. The next step in order to check for extraneous solutions is to plug your solutions for x, those values, back into your original equation. So we're going to go ahead and do just that here for equation number 1. So the first step, like I said, is isolating the radical by adding +2 to both sides. So then I said we needed to square both sides. So I'm going to go ahead and rewrite it with x plus 2 squared is equal to 9x plus 18. Then we're going to go ahead and FOIL this side, and then we'll set this side equal to 0. That's the next couple steps that I'll be doing here. So I have my x squared plus 4x plus 4, and then I want this to be equal to 0. So the next thing that I'm going to have to do is take away 9x and take away 18. So that's what I'm doing over here. So now I have x squared, 4 minus 9, or negative 5x, 4 minus 18, negative 14 is equal to 0. So now I can go ahead and factor that. So I need to find the two things that multiply together that give me negative 14, which means one will be positive, one will be negative, and then they also need to add together to be negative 5. So easiest way to write it, I've got my sets of parentheses here, x's, so I know one has to be positive, one has to be negative, because again, when you multiply it together for it to remain negative, it can't be a negative times a negative or even a positive times a positive. So they've got to have one of each. So since this negative 5 is more on the negative side, and my factors of 14 include like 14 and 1, but also 7 and 2. So I'm going to go ahead and guess the 7 has to be the negative one, while 2 will be the positive one, since it's on the more negative side as opposed to being a plus 5x. The next thing, these are my factors or my roots or my zeros. So I'm going to go ahead and set it equal to 0 here. So x minus 7 is equal to 0 in the same way that x plus 2 is equal to 0. The way you would get there is just dividing both sides by x plus 2, that factor, or x minus 7. So then to solve for the x, you do the reciprocal operation and you're left with x is equal to 7 and x is equal to 2. So we're going to go ahead and plug these back into our original equation. I'm going to start it down here and then bring it back up. So what we've got here to start is 7 is equal to the square root of 9 times 7 plus 18, and then we can't forget that minus 2 on the outside over there. So this is the same as saying that 7 is equal to the square root of 9 times 7, or 63, plus 18 minus 2. I'm going to go ahead and bring it up now. So we've got 63 plus 18. And now over here, we'll have our 7 is equal to the square root of 81 minus 2. And that's the same as saying that 7 is equal to 9 minus 2. 7 is equal to 7. So we can check it off. It isn't an extraneous solution. We need to go ahead and plug in x is equal to 2 the same way. So we're going to go ahead and do that right here. We have 2 is equal to the square root of 9 times 2 plus 18, take away 2. 2 is equal to the square root of, oh, my bad, don't forget that should be a negative 2 there. We want to make sure we have the correct signs. So when we multiply that out, we'll have negative 18 plus 18, or 0. So it's going to end up being a 0. And then we have our take away 2. So this whole time, this was negative as well. So negative 2 is in fact still equal to negative 2, and we can check that off. So again, this particular equation did not have any extraneous solutions because when you plug them both back into the original equation, it got the same answer. So that's all we need to do in order to check for extraneous solutions when you have a radical equation. We're going to take a look at this next one here. So this one, the radical is already isolated, so we can start just by squaring it. So we raise that to the second power in the same way that we do this. So when you have x minus 6 squared, again, we're going to go ahead and FOIL it. So it'll look something like this. You've got your x squared minus 6x, or minus 12x plus 36. So we're going to set it equal to 0. So now we've got our 0 is equal to, also the way we do that is by taking away 3x from both sides. It's going to be equal to x squared minus 15x plus 36. So we need to figure out what our factors of x are going to be. In this case, when we multiply together to get 36, since it's positive, we know both of our factors are going to have a negative in the middle this time. So it's going to be x minus something times x minus something. So our factors of 36 could be something like 2 and 18, 3 and 12, 4 and 9. Righty. Obviously, you've got 6 and 6 as well. But since we changed it, we know we can't still use the 6 and 6. And we know as well that 3 and 12, for example, they would add together or subtract in order to get 15. So that's our most likely option. So we're going to go ahead and plug those in for our factors, for our options here. And now we set x minus 12 is equal to 0. So x is equal to 12. And x minus 3 is equal to 0. So when you add 12 or you add 3, now you've got x is equal to 12 and x is equal to 3. So we plug that back into our original equation. If we have the square root of 3 times 12 is equal to 12 minus 6, we've got the square root of 36 is equal to 6, and 6 is equal to 6, so we can check that off. It's not an extraneous solution. Now we have to plug in our 3 the same way we just did, and we'll see how it works out for us. So now we've got the square root of 3 times 3 is equal to 3 minus 6. So the square root of 9 is equal to negative 3. 3 is not equal to negative 3, so that is going to be an extraneous solution for this particular problem here. All right, so again, you do need to go through those steps in order to verify whether or not it works with your original equation and therefore becoming an extraneous solution. For our last problem, the only difference between the first two and this one up here is because of the rational exponent, but you can rewrite it as a radical or vice versa. So we're going to need to raise it to the reciprocal power. So in this case, it's to the 2/3 power. So we're going to need to raise it to the 3/2 power in order to cancel it out. It's basically the same as squaring a square root. So also keep in mind that you've got your x, and it's going to be exponent over index. So that's how we know what the 2 is representing. That's representing the power, whereas the 3 is representing the index. That would be a cube root. So we're going to see more of that here real quick. So we're left with just a basic x minus 5 is now equal to the square root of 4 cubed. All right. So we've still got our x minus 5 is equal to the square root of 4 times 4 times 4, or 64. And now x minus 5 is equal to the square root of 64. So x minus 5 is equal to 8. But considering this is an even index, we want to also take into consideration that it can be our plus or minus options as well. So I'm going to go ahead and write it right here, plus or minus the square root of 64. That way we have an x minus 5 equals 8, but we're also going to go ahead and take it in the other direction. So x minus 5 is equal to negative 8. And we'll solve for both before plugging them back into our original equation to check for extraneous solutions. So we add 5 to both sides, and now we're going to have x is equal to 13 and x is equal to negative 3. So we're going to go ahead and plug these back into our original equation and see how it works out. So now for our first one here, I'm going to go ahead and draw this little line so we can make sure we're not getting confused. So 13 minus 5 to the 2/3 power is equal to 4. So that gives us 8. And then basically what it's saying is it's going to take the cube root and it's 8 squared. So it's at 64. Remember, another way we broke down 64 was being 4 times 4 times 4. So we know that it is going to be able to be simplified within a cube root. So I'm going to go ahead and rewrite that now. So the cube root of 4 times 4 times 4, well, we have enough within this index, that's how many we need, to move it out. So we've got 4 is equal to 4. We can check off x equal to 13. It's not an extraneous solution. So now when we plug in the negative 3, we'll have our same equation. Inside the parentheses, negative 3 minus 5 to the 2/3 power is equal to 4. So guess what? It turns into the same thing. It'll be a negative 8 squared, and then the cube root of that. So 8 times 8 is the same as negative 8 times negative 8. So we know it's going to turn out the exact same way. So we'll have the cube root of 64 is equal to 4, and it still is 4 is equal to 4. All right, thank you for tuning in to this lesson on radical equations and extraneous solutions. Remember to like, comment, and subscribe.